to speak to us today. I'll be giving a quick introduction in a second, but yeah, just please everyone make sure their mics are off. And yeah, thank you very much for coming, Andrea. We're very grateful to have you. Yeah, so as a quick introduction, Andrea Jalandoni is a senior research and DECRA fellow based at Griffith and the Australian Research Centre for Human Evolution. Her research interests are rock art and digital archaeology in Australia, Southeast Asia, and Micronesia. She's part of a recently awarded Centre of Excellence for Transforming Human Origins Research, which will hopefully bring her down to our part of the world sometime soon. Some of her current projects in Australia include creating digital twins of rock art sites to study rock art placement, facilitating community access to bark paintings through VR, archaeological predictive modeling, and using AI and experimental archaeology to develop new methods for studying finger flutings. In the Pacific, her current projects are combining LiDAR and ethnography in Pohnpei and Kosrae, and shoreline change monitoring in the atolls of Ulithi. As a recreational pilot, she's also interested in aerial photography and flying herself to work in remote areas. Thank you very much, Andrea. We're very grateful to have you here. Please take it away.
Thank you, Andrew. Yeah, I'll just get right into it. Let's share the screen. So if any of you have seen me present this before, it's usually I update every year. I think I've started this in like 2022, and every year, sometimes forget to change the year, but I do update the slides. As I mentioned to Andrew, I do hope people have already a background on photogrammetry and all that, so I won't get into the very basics, but I'll just sort of talk more of what we're doing, with the basics and how we're taking it a bit forward. Okay, this is a slide I haven't changed very often, but it's just, one of the reasons why we need to be recording rock art. All the destruction going on, and this is just in Australia, and this is, just within a few year time period. I think 2021 to 2024 or something might be the most recent, or 2022 actually. So within a short period of time, so much rock art, it's been destroyed. These are some of the tools we use. So, well, I use, which are, I have a terrestrial laser scanner on the left. It's very light and portable. I just got upgraded to a G2 from the G1 of the BLK 360. The one beside it is a GeoSlam. It uses simultaneous localization and mapping. So it is one of the scanners you can walk with, which you can imagine is very useful. But of course, with the mobility, you lose some of the data as well. Smart glasses, which I've just integrated for interviewing. A lot of the community members and the Indigenous people I work with, when you're holding your phone even, or some sort of camera, it's very confronting. But if I'm wearing these glasses all the time, and we have agreements, they know that's not like I'm a surprise recording them, by the way. We've signed consent forms and everything. I've explained to them how it works. And there is a light that turns on when I record, and I usually say, I'm going to start recording, and they say, okay. And then it just becomes out much more natural for them to talk and tell stories this way and catch things right as they're happening. Beside that is an SLR camera I use, which I'm sure a lot of you use as well. And of course, you're familiar with drones, and a 360 camera that we use. This is the InstaPro 2, I think, 360. So, like I said, I'll just jump through. I won't go into details about photogrammetry and laser scanning, but this is one of the things that not everybody knows you can do with a laser scanner, or at least there's a chance that you can do it, is finding hidden rock art. So the laser scanner isn't just for good geometry, which of course that's probably its best use, but by chance, by accident, I found I could find rock art underneath this. So obviously when I was in the Philippines and I saw this panel, it was like all graffiti and, the moss growing over it. And we were surprised that rock art came out when you looked at the reflectance value. So using the intensity values of the laser scanner, you might be able to find more rock art. I published this paper in 2019. Oh, sorry, I did the work in 2019. Of course, it took a while to get published in 2021. And just recently, a master's student from Germany used the work to see if she could, because I was telling her, look, it'd be amazing. What if we could isolate the value for graffiti? And then if you're confused about whether it's rock art or whether it's graffiti, if it's not made in the same material, let's say, then they would have different signatures. And she's done some experiments on it. I think her thesis, she just submitted it recently. I still haven't had a chance to read it, but I think she's finding, which is what I also suspected, is maybe I just got lucky, because you have to have the laser scanner at a very specific position for it to capture the data that you want it to capture, like a certain distance from the rock. But I mean, even knowing that this is possible, I think opens up some avenues that other people can explore. Sorry? Okay, well, okay, what we're seeing here is a photogrammetry model and a laser scan combined. And sorry, I'll go back to that. This is one of my favorite examples. It's one of my first examples of combining them. So I think I did this in 2019, and using reality capture, I was very pleased at how easily they merged together. I mean, of course, it's the circumstances of this rock shelter, good light, great overlaps and all that. But it's a very famous site in far north Queensland. And I think about 2 years ago, so maybe 4 or 5 years after I made this point cloud, I was contacted by someone who heard that I had made this. And this is what I quite like, because sometimes you make these 3D models and then, I'm happy with them, but no one ever sees them. Like, what am I going to do with them unless I publish them? But then, community permissions, and I have to have a research question. I think some people think, oh, you just make a 3D model and you can publish an article on it, and you can't. You have to have a research question. You have to, go through the ropes and everything. So unless I have something specific, no one ever sees it. But in this case, one of the Aboriginal community members is actually a well-known international artist. He's a portraiture, Vernon Aki. He heard that I had this point cloud, and he was super excited because he's interested in his art practice, engaging with modern technologies and new things as well. So he put together this exhibit called Way to Be, and he used the 3D models. He used my point clouds and incorporated them into this whole exhibit. And he really likes, so someone there is controlling it. You can zoom in, go around, fly around and all that. And he liked that, you're able to have new perspectives of the rock art this way. And what he liked doing a lot was showing people, look, if you zoom in, and then he walks up to it and he puts his hand over a stencil to sort of feel that connection to the rock art this way. And yeah, it was just a lovely way to see the technology being used and being engaged with by the people who own the cultural heritage, who own the stories. Something else I ended up doing quite a while ago was de-stretching 3D models. I think this is pretty common now, but at the time I didn't see many works or any works that had done it, or at least not published on it. So I decided to publish on this as a part of also creating and helping to create inventories using 3D models. And it did help, being able to see rock art, which you might not be able to see otherwise, as you all know, because once you de-stretch it, the colors are stretched and you're able to see it a bit better. And then it helps with, doing visual change detections as well. When you line up the point clouds, you can, and this is the difference between when people say, oh, but I have an old photograph and why do I need to do a 3D model? I can just take another photograph, but you can never align them as well as you can if you put them on 3D models. So even an old photograph from here, the 1992 one, I can put it onto a 3D model I made in 2021. And then we're able to really see the change, at least visually detect it. The next step, of course, is to metrically detect it, meaning if you did 3D model over 3D model. And this is just something we included in the publication as an explanation to why the rock art degraded so quickly in that site. a cyclone had passed through the area, cleared out the trees, and changed the whole microcosm. So another thing, this just came out last month, is we've experimented with a localized D-stretch. So as you can see from these images, you can read the whole publication and see even more examples, how, with the usual D-stretch, some things are lost. And that's because what regular D-stretch does is it uses the whole image, and it stretches all the colors in that image. And what ours is doing is breaking down that image into smaller images so that there's less contrast in one image. You'll notice the problem with the usual D-stretch. If you have just a little bit of sky, and that throws it out. If you have a scale card in there, that'll throw it out. But with ours, it wouldn't matter because it's breaking it down into little bits and then stretching each one individually. This is a new decorrelation app by Mark Willis. It's not yet out yet, but he sent it to me to beta test. But I think one of the most impressive features with this is the live function, which I think we've all wanted in our ID stretch or our Android D-stretch apps, to be able to be at a rock art site and move it around and not just keep taking the picture and stretching it, taking the picture and stretching it. Now you can stretch it live. And he incorporated our localized D-stretch into his app as well. So there are some new things happening. This is something maybe Jeanette remembers, because I think when I met her, I presented this at that conference, just as still during my PhD, of a way of enhancing engravings. And I did this in the Philippines as well. So from some rocks where you can barely see the engraving, by using a 3D model and enhancing the 3D model, the topography, which exaggerates the difference in elevation, you're able to really see the rock art. And we used to do the manual tracing, and we compared it with manual tracing, and we just saw so much more. So this is an example, what you look at when you have the photograph. And I picked rock art here that you could actually kind of see a little bit, And then what people were doing before I did my, 3D model and algorithm, the TPI enhancement, was that they were still using D-stretch on it, which is not a tool for engravings. It's a tool for paintings. And this is a difference that you could see with the method. We built on that a little bit more and decided to come up with use other algorithms to do the automated tracing. Now, I think what's interesting here is how much it's kind of like, you're still making the decisions, right? It's not like you're getting the optimal results every time. You have to decide what sieve size you're using. And, for those of you who excavate, if you're, when you're choosing your sieve size, there's all these factors that come into play, right? If you pick something, the hole is too big, so much falls out, and you only get the big stuff, which is what you see here at the bottom left with the 900. But if you pick a sieve size that's too small, you get a lot of noise, is what you see on the top right corner there with the 100. So you have to make those decisions the same way you do when you're excavating and you're sieving. Before I move on, another point of this is I saw a presentation at WAC last year where they took this method and they applied it on a microscopic level, and it worked well too. So it's nice to see other people using it and taking it forward a bit. Another thing I was working on was I got asked to work on this finger fluting site in South Australia, in Quenelda, to record the finger flutings in this cave. If you look at this picture on the left, you have to rappel down, and then you walk in about 100 meters or something of darkness, and then there's all these finger flutings. It's quite an amazing sight to think that people went there and left these finger flutings. If those of you not familiar with finger flutings, it's a very esoteric form of rock art, and some people may not consider it rock art, where on a very specific type of limestone called moon milk, you can swipe and leave your marks as finger swipes. And what I had to do here was try to figure out, of course, you're thinking, well, you can just take a bunch of lights and do a regular 3D recording. We could have, but it's a bit hard to bring the lights down, as I've described, hard to bring them in. There's some environmental implications with the batteries and everything, or, just things that you have to consider, like if the battery just gets damaged. And anyways, so instead I thought, well, I'm going to do flash photography, which is again also not recommended for usual photogrammetry. If any of you have read the Agisoft manual, though that's changing too, I think it's not as difficult as it used to be. And the other option was to try something new. So my good friend and colleague Rob kept encouraging me to try chiaroscuro, which I was very hesitant because I was like, no, it's not going to work. You need really good light for photogrammetry and everything. But anyways, we did some experiments, not on rock art, but on we went to a park and we recorded a tree and the rock at dark. And I was pretty surprised at how well it worked. So chiaroscuro refers to the use of light and dark to create a three-dimensional volume. It's very famous during the Renaissance period. And then we looked at Darren Jew used it for this really great photograph underwater. And as you know, underwater photography is very difficult to get the lighting right. So he used this sort of technique. And then this one as well, Robin Wu, for the cover of that Nat Geo one on Stonehenge. It's so gorgeous because he's using drones, waving lights around and everything. So we thought, okay, let's give it a go. And just to give you a bit of an idea of the technique, it's just moving the light around like that. You take a longer exposure. And we were really pleasantly surprised with the results. That's how clear it looks. And this is the 3D model zoomed in. And then if you just want to go through the process, you can make the 3D model. If it's low light, you can use the chiaroscuro, and then you can enhance the engravings, and then you do the automated tracing. And then you can, do fun things like group them together how you think, every individual swipe was and which ones overlaps which. Now a bit about machine learning. So what I ended up finding towards the end of my PhD and the beginning of my postdoc was that I had so much data, because if you do photogrammetry, right, well, other people take maybe 10 pictures at a rock art site, you're taking maybe 100, depends. But the point is I had so much data, and I thought, well, we have to find more ways to use the data. It can't just be, I'm just taking have this data and I just make a 3D model. I have to do more things with it. And so I went to an intensive data science week-long workshop, and I came away with some basic concepts of it, but more than that, I came away with people who wanted to collaborate with me. The person giving the lecture, I told him about the rock art, and he was interested in working together to see what we could do. So I thought, okay, let's do a basic proof of concept for how it could work for rock art. And we came up with this work of identifying whether or not a photograph had rock art or not. The difficulty is because my data set is very biased. I have so many examples, so many photographs of rock with rock art. I don't have many examples of rock without rock art. And this was just about the time COVID happened, travel restrictions. I couldn't just easily go out and get more data. But the writing of this paper, the publication took so long that I actually did get to go back out to the same area and collect photos of non-rock art, which was probably pretty confusing for the tourists who saw me taking pictures of just blank areas of rock. They're looking like, what am I seeing that they don't see? But yeah, so that was that project. And another part of that paper was sort of envisioning, well, what other typical uses could we have from rock art? That's the area where the rock art is from, I kept the data collection to one specific area. And these are some of the things we thought of: object detection, motif extraction, knowledge graphs, image reconstruction. And I've had a bit of fun over the last few years going to different presentations, reading different papers, and sort of playing my own machine learning and rock art bingo. And, you know, these things are happening. Like, okay, this paper, object detection was one of the quick ones that came out. And then motif extraction as well. Like, I saw a few examples, a few different ways it was being done. Knowledge graph, I haven't seen too many, but there's definitely, I talk about it. Like it's coming out soon, as well as image reconstructions happening as well. So, and there's more. I mean, of course, I couldn't envision everything that machine learning would do for rock art, but there's so many things happening right now. This was another project in far North Queensland that didn't quite finish because of internal disagreements. So it got halted at a certain point, which is a pity because it was a very interesting project of using drones to find the rock art, and then I'd go out and verify if there's really rock art there or not. And so, you know, you create a predictive model, you prioritize searches, you schedule the drones to go fly a certain area. And we did find rock art. We found new rock art sites using this method. We stopped at about, I don't know, step 4, step 5, I think, before we had to cancel the project, which is unfortunate because the next step was to really make this automated with BIVLOS drones. So our idea was, this is a very remote area of Australia. You would set up a BIVLOS drone, a beyond visual line of sight drone, that's just connected to a Starlink and some solar panels for power. And then, you know, when you're 1,000 kilometers away in Brisbane, you could send the drone out to do a certain area to scout out, and then the data would feed back, and you know, using the automated detecting whether or not it has rock art, then it would alert you if it found any rock art, and you know, it would be a very cool process that way. But we didn't quite get to that level. We stopped right before purchasing the BIVLOS drone, I think. Back to the finger flutings, this is another thing we did with the machine learning, which was, so previous research in finger flutings looked at always measuring stuff and, you know, trying to physically measure it, which, you know, is very problematic because you can't actually touch the art, right? It's very fragile. And you're so measuring them, sort of air measuring them, and doing the, you know, analysis that way. So I was trying to think of a completely different way to approach the problem. And I thought, well, let's try to use machine learning. Let's see, not based on measurements, but based on the machine learning things that maybe we don't, nuances that we can't really see, to determine, well, the first question was whether or not it can determine male prints from female prints on modern populations. Again, I'm very, very clear in the paper, and whenever I talk about this, that this is just conceptual. This is just proof of concept. We're not yet nowhere near the level that we can apply this to actual finger flutings, archaeological finger flutings. In fact, one of the reviewers commented, like said that, no, you need to apply this. And I wrote a very strong response, and like, that'd be completely unethical. There's so many implications that go into, you know, whether it's male or female, and what might happen. This is nowhere near ready for that. This is just showing whether or not can a machine tell from a modern population if you finger flute, if it's male or female. And we tried 2 different collection methods. One was tactile and one was virtual. So the instructions were something like this. We wanted different, because we also don't know if, you know, we have ideas of how people finger fluted, but, you know, we thought, okay, let's collect different kinds of data, different ways of fluting as well, to have that data too, though we haven't done anything with it. But those are the instructions you had. If you're wearing the headset, you had the one on the right, and then you had the one on the left when you're doing the tactile one. It was actually fun also to do the tactile one, because previous research, they used materials that were nothing like moon milk. And during COVID, I started doing pottery. So I went to my pottery teacher with a sample of the moon milk, and I asked her to replicate something like this. And I sort of described to her and showed her pictures of what the finger fluting is supposed to look like. So the material needs to do this, but we also need to be able to erase it after every go and then flute again for the next person. And she came up with a formula. We also published it. It's also part of the in the report. And these are the results. Pretty much the tactile did much better than the virtual. But even the tactile shows signs of overfitting. So I guess our conclusion, as usual, is we need more data. But my second conclusion is I don't think I would do this project the same way the second time around. I might team up with a larger team collecting data on other things and just ask them to incorporate what we're doing, because it was a lot of work, even collecting. I think we only had 96 participants doing both virtual and tactile, though they didn't all do both, but most of them did. It was a lot of effort. And if we did the virtual again, definitely maybe haptic gloves would have been good. Maybe sensors tracking eyes for other information. Yeah, there's so much more that can be done in this space again. And I'll talk a bit about virtual reality and some of the things we're doing there. So this project was born out of one of our grants to study bark paintings and rock art in Arnhem Land, again in Northern Territory, Australia. And it's been a great project in the sense that, like, these bark paintings have such a strong relation with the rock arts. The same people who painted rock art also made some of the oldest bark paintings, and they're related to the community members. Like this guy in the middle here in the yellow jacket, it's his grandfather who painted that big crocodile. And so they got to go to Melbourne to see it. Melbourne, in fairness to Melbourne Museum, they've been offering to send it back to the community, but the community members know that they can't take care of it. You need like climate controlled area. These barks are fragile. So I went and recorded them and made them to 3D. Of course, I didn't do the bottom, so actually they're like just the top parts are 3D. And when we're trying to think of how do we bring this back to the rest of the community, because they can't all come down to Melbourne and see these bark paintings. And we have these 3D models, what can we do with them? And I thought, well, I had this PhD student who was doing virtual reality. Why don't we ask him to take the 3D models I make and put them in a virtual environment? And I thought, didn't expect him to put much effort into it. I thought, yep, just put them onto a headset that we can all just walk, like maybe even twirl around and just see. But no, he really took it on. So he did research as to what these bark huts used to look like. And then he did his first iteration there on the left. You can see it. His name is Callum Farrar. And he took that to community, and they mostly laughed at the environment a bit because he had never been to Arnhem Land, Northern Territory. So he had no idea what it looked like. So the second time around, after he'd seen it, he created this one, which the community loved. It looked very much like, the sandstone of the area, the color of the ground is correct. They love the elements like the trees and the fire. And, they could interact with the bark paintings too. And then we did. And they had other suggestions. They wanted dingo. They wanted an animal going through, make it really more like a campsite. They wanted to be able to draw their own bark paintings, virtually. thing. I'm not sure why it keeps stopping, but there. And so we have that also in different colors, not just black. We added that. Another thing they wanted was mimes. Mimes are these like mischievous spirits. They wanted mimes running around as well, like jumping into the rocks and out. So Callum drew a version of a mime and he animated it. I was in the field with some of the binning, some of the community, and I showed it to him. And you know, the people we work with, they're artists, right? They're continuing to paint bark paintings and paper paintings and stuff. Um, so I showed him Helms and he said, no, I'll draw one. So he drew one there in the field, like 15 minutes. He drew this, what he visions a mimi to look like. And I sent it to Callum, still in the field, and Callum quickly digitized it and animated it and sent it back. And that was the animation. I showed it to Sean again. I'm like, okay, look, how do you like these? Like, yep, looks good. But I could tell that Sean wanted something a bit more. And I was like, okay, well, what should he change? And so he demonstrated, I want the mimi to move like this, you know? And so we animated the mimi how he wanted it and then put it in the VR. And I don't know if any of you went to WAC in Darwin, which was very convenient for me because it, you know, it's really near. It's really near, meaning 300 kilometers from where I'm working or from where my field work is. And Callum did the augmented reality exhibit. If you were there and saw that, and where you could interact with the bark paintings. There's some information on the side there. And there are the mimes all around as well. You can interact with them too. And I'm going to end with the big project I'm working on now, which is revealing ancient decision making by applying digital archaeology. So the whole concept is to record the whole hill in 3D, record every rock art site, and annotate every figure. And I remember one of the comments of a reviewer was like, you know, it can't be done. It's too much, too big. But I think that, you know, if you understand digital archaeology, you understand that that's very possible. And especially if you work with community and you work with other people, you know, you can make something like this happen. So that's the area. Gumbalanya is the community and Yulak Hill is the site, the hill, yeah. And it started with a workshop I did in 2021 where I taught a few of them how to do photogrammetry. And they loved it. They really took to it. They enjoyed the technology, but they also enjoyed going up the hill. And they kept asking me every time I saw them again, oh, when are we doing that? When are we doing that? So I'm like, okay, I'll write another grant and we'll do it. And so luckily I got a grant. Oh wait, I'll show you a few pictures from that 2021 thing of me teaching them and then them doing it. In fairness, they don't want to process it yet, but maybe we'll get there eventually. They still just like doing the fieldwork part, but who can blame them? And this is one of the 3D models they made. And what's great about working in this community with them is that they have the story of this rock art. They can tell you what it is. I could probably tell you too, but when I've asked Joey, he said, no, tell them to come to me, take a tour of the hill, and I'll tell them the story. And I'm like, okay. So we continued last year in 2025. I think we've recorded, my estimate is about 80% of the hill. We've added other things like this, we're tracing on the iPads. I'm collecting, like I mentioned, all these pictures are taken with the smart glasses. They're sharing stories. I'm just recording them. Cut out the video. They're talking about the rock art. And we have some early results. Well, some of it is, you know, Joey enjoys teaching Balanda or people who are not the Aboriginal people. And he likes teaching the Binning, the Aboriginal people, especially the kids. And we've collected 360 imagery, which is good for, this is just satellite imagery showing the locations of where we've taken it. This is some of the imagery from the 360, which we are also doing some Gaussian splatting experiments. So that'll come out maybe end of the year or maybe next year. And then we are, of course, making a 3D model of the whole hill using drones. This is just to show you the contrast of how much more detail this hill has versus the surrounding area. But of course, if you zoom in more, we'll have even more detail. This is the combination of why I do photogrammetry, which you get very good colors and detail, but the laser scanner just gives you more context. You know, you're able to connect it with a broader area. And if you combine it, then you get the best of both worlds. And this is a bit of an example from just one section of it. So you have, this is parts taken with a drone. So you can see how good the resolution is. But the drone doesn't get underneath the rocks, right? And a lot of the rock art is underneath the rocks. Well, underneath the shelter, the ceiling. Anyways, you understand. And then so that's why you need the laser scanner to get that section there. And then to get the rock art in good detail, you use the camera to make the 3D model there. And then you annotate, someone has to annotate it on the iPad, and that was Joey. So we had the local community doing all the annotations. And he's annotated a lot of it, and the rest of it we're trying to create a machine learning model to be able to work through most of it, the rest that he hasn't annotated. An interesting part of this project has been he's been classifying it according to his own ontology, and that is just it's a super fascinating part of this work. That's what it looks like to be putting the all the tracings back onto the 3D model. And if you can imagine now, especially we have the data, we have all the annotations, we're going to have the knowledge graph, which means creating the spreadsheets. We'll have all that information. And that's partly why I'm here in Spain, to work with Inés Domingo Sanz more on doing more spatial analysis and what questions we can ask. I mean, I have the questions I propose to ask, but you know, now that we actually have the data, there's other things we can do. So that was Joey, and he's saying he wants to learn more things about rock art. And while he was tracing the rock art, he made an amazing discovery, which is just published last week, and it's been in the news. And for those of you not familiar, thylacines have been extinct in this area for what they think is a few thousand years. So to find another thylacine, we have a few examples, but everyone is very special. And it's been fantastic for Joey to be able to, you know, to be on the project and be able to identify them. And I think that's it. Any questions? Anyone still awake?
Yeah, thank you so much. That was really fascinating. These are amazing projects. Yeah, does anyone have any questions? How does one get on the mailing list for the live D-Stretch app? My word.
Ooh, I know. Cool. Cool, right?
Yeah.
Will be announced. I'll let you know when it's available. Yeah. I can send it to you, and you can send it to the rest of RARI. Yeah.
Thank you. Nobody? We're just all in awe. I'm in awe.
No, thank you.
The community engagement element is really interesting because I think, certainly I'm used to seeing, folks come in with a sort of hard science perspective with these things and be very kind of sterile and cold about it. So that annotation process, what sort of software are you you're just taking a shot with the iPad or a model of the iPad and just sketching
So
straight on?
yeah, we tried a few things. This is our first time to try this process. But I'd seen other projects that had used an iPad and tracing, and I thought, we can do this. Yes, initially we were just taking pictures of the rock art, and of course you can de-stretch them on the iPad, and then, they use Procreate to trace. And then with the more complicated ones, like the really big panels, like needs high detail that the camera of the iPad won't suffice, then we created 3D models from the SLR, and then we made ultramosaics of those, and then we did the stretching there, and then put it back on onto the iPad for them to stretch for them to trace. Usually, we try to do as much of the tracing as possible right by the rock art in the field, because you can see him. I have videos of him. He's tracing and he's looking at it. He gets up, he gets close, he has to do it again. I think honestly, the best part about having the community trace is if anybody objects to the interpretations, I think they're out of line. I mean, if I did them, and if I was like, nope, this is a kangaroo, someone might be like, that's not a kangaroo, and what can I say? But like, I'm like, well, the community says it's a kangaroo, that's what we're going with. And yeah, it's been a real pleasure to work with them. They have so much knowledge, and so the challenge is also trying to find ways to integrate that. One really good way I thought was, yes, having them classify things themselves, and it's been super interesting because it's not Linnaeus at all, and that'll be really good to thresh out a bit more.
Anybody else? Well, then, unless anyone else puts up their hand, I will say thank you so much for coming and talking to us today. This is really special. Really appreciate it. It's quite amazing seeing the things that are possible at the moment. Yeah, thank you so much. Yeah, and thank you to everyone who came. This will be going up online hopefully in the next couple of days. Yeah.
Okay, thank you, Andrew.
Thank you very much, Andrew, and thank you, everyone. Keep well.